Hello, I am Vishwas Datte, Principal Product Manager in Bentley Systems. Today I am going to talk about RCDC, our Advanced Concrete Design Solution. I will talk about how RCDC fits in project lifecycle for a structural engineer. What are different capabilities of RCDC? What is this general workflow in RCDC? What international codes are supported and different types of outputs that we give. For a typical project, the life cycle of the project starts with the schematic stage or a preliminary stage at which uh, generally structural engineers perform a preliminary analysis, coordinate with architects or process consultants for industrial structure and finalize the structural scheme. Once that is complete, actual detailed structural analysis takes place in which engineers generally apply all the gravitational forces, all the lateral forces and whatever is the required thing to do. Once the analysis is performed, generally engineers will check the stability parts. So whether the deflections are in control, whether the mode shapes are in as expected manner, and all those things. And once they are sure of that, they will generally go for design. During design, the first step is to actually arrive at the area of reinforcement required for various parts. So be it column, be it beams, be it shear walls, be it slabs. Once that is done, then the second stage comes wherein the actual rebars are placed depending on the section. After that, generally engineers will follow through to create execution drawings which are shared at site. And at site, they will be further enhanced to go into fabrication drawings or what we call as bar bending schedules, which will be actually executed during the reinforcement placement. Simultaneously, structural engineers generally work create reports for submission to authorities or peer review and also create reports for quantities which are very important from the costing perspective. So this is the total life cycle for a given project. RCDC actually handles this portion. So post analysis, it allows an interactive solution for clients to finalize the design and detailing together. And this is an important thing. It is not that you complete the design and detailing is a separate activity. It is together. And once that is done, further outputs, whether it is drawings or calculation reports or BOQ, is combined. All of that in one go. And that is how RCDC fits into a project cycle. Now let's look at salient features in different design capabilities. For columns and shear walls, RCDC can handle practically any shape along with rectangular and circular. It can detect continuity across elevation, across the levels of the building. It can handle ductile or seismic detailing, including joint checks. If there are shear walls, it can identify whether the boundary limit is required and can detail accordingly. Slenderness calculation it handles on its own depending on the parameters set by the user. And it can also allow users to group the columns for design in plan and across the height. So in a way, if your building has four corner columns which have similar loads, and say your building is multi-story, so you don't want to change the design across the height, then you can group those four columns and also group the 4 or 5 levels that you want to produce a single design for all those columns. For beams, it can handle normal rectangular beams as well as T or L-shaped beams with slab contribution. It can handle ductile detailing. It can also handle design with axial force and biaxial bending if need be. In some cases, when there are high axial stresses possible in a beam, it is better to go for this. As in columns, RCDC can handle continuity of beams in plan. In a sense, if there are multiple beams forming a group of columns in a frame, then it can handle that design together. It auto identifies the groups based on the continuity. And very importantly, if you have a building with typical levels which have similar arrangement, then if you don't want to change design across multiple levels, then you can design all those levels simultaneously. What RCDC does is internally it will create a maximum design for all those levels. So you will never lose the worst section possible across the levels. Coming to isolated footings, RCDC can handle isolated footings with very simple basic design parameters. There is a logic to automate the sizing, including the stability checks. If users want, they can provide a variable SBC depending on the proportions L by B or depth or whatever. If groundwater presence is there, RCDC can handle the reduction in the weight, for the pressure checks. If you want to design footings with loss of contact, typically an industrial shade with very less loading can experience this kind of requirement. If need be, you can design eccentric footings. For some columns, if you have some restraint on one side where you cannot exceed the footing by, let's say, by 500 millimeters, you can put that as an input and RCDC will size the footing based on that constraint. Similar to columns, it can design a footing for a group of columns. So it means that if you consider 4 columns which have similar load and you design the footing, it will create a design that satisfies all the requirements for all the columns. It can handle isolated pile caps in a way up to 6 piles. So if you have a regular arrangement up to 6 piles concentric to the column, then it can handle a design. In fact, you can create option with multiple pile diameters. So you might want to try out 3 or 4 different pile diameters. You can give that as input and RCDC will provide you different arrangements which you can finalize and then complete the design. It can handle factor of safety for a single pile or a pile group. And as in footings, it can design the pile caps for a number of columns together. It can also handle slabs which are beam supported and not flat slabs. So in many cases, people don't model these slabs in a STAAD model. They only add contributory loading, in different perspectives. So in this case, RCDC can auto-detect the slabs. It will also auto-detect the continuity across various panels. Of course, complete the design for bending and shear, perform the empirical check for deflection. If required, it can handle design of one-way slabs for special loading cases like a triangular load or a concentrated load or a partial UDL and so on. Let's look at RCDC workflow, how it runs. So first step will be to read the data from a STAAD file, for example. Once the analysis is completed, then it allows you a simple design parameters settings through a dialog or a form in which you fill certain values. Some of these are pre-filled and you need to edit only those which you want to change. Handle the load combination, so you can segregate different load combinations, sizing for a crack width or a design ultimate limit state and so on. It has a very interactive design detailing tool. So in this case, for example, this you are seeing is actually the reinforcement provided and required graph for a beam. So for a top, for a bottom, and for a shear reinforcement. So it's very interactive, it's very graphical. Or this is a PM curve for a column, in 360 degrees, if in ACI codes and so on. Or for a shear wall, you can actually review the arrangement, how the bars look like, check the importance of that, maybe finalize the length of the boundary element differently. You can perform multiple iterations or you try different combinations, and once you are comfortable, you finalize the arrangement. Once you finalize the arrangement, of course, something that you want to do is check the calculation. So it provides you detailed calculation reports, which are like textbook, for example, and very step by step. Once you are satisfied with the report, then you can proceed to outputs. So you can generate drawings. For example, this is beam elevation, this is column details, or you can generate BOQ and other reports. Now let's look at the codes that are supported. So currently RCDC supports ACI 318 metric as well as ACI 318 FPS units, 2011 and 14 versions. Eurocode, it supports the base code as well as UK, Malaysia and Singapore annexures. It supports Indian code. Philippines code, and the old BS code. And very soon it will support Australian code, 2018 version, and Belgian code, annexure for the Eurocode. So let's look at some of the drawing outputs that are possible. For columns and walls, it will generate the detailed cross sections based on the arrangement of rebars. So it will show the size, rebar, the link arrangement, everything. For shear walls, it will also indicate the boundary zones and also the mid zone separately. It can handle combined shear walls, so it will design individual arm of the wall as a single wall, but when it details, it will detail the combined wall. Or it can handle columns of practically any shape. So you can see some standard L, T, I shapes, or a capsule shaped, or a polygon specific, or it could be absolutely irregular shape as shown in the last. It can generate column elevations across the levels, showing the laps and everything, including the confining zones for the special ductile links. Coming to beams, it can generate detailed elevations, and also it is possible to generate text schedules. And for each elevation, it will generate automated sections with intelligence. So in a way, what we do is we track the beam from one end to the other end, and wherever the change of reinforcement occurs, we draw a section. It is all automated, intelligent. For footings, it can generate the foundation layout with PCC marking also if you require, including the grids, even if they are not in the analysis. We'll see that in a demo a little later. It can generate the plan details, in-plan details for footing or the cross-section. It can handle step footings as shown here, up to 5 steps if required. For pile caps, it will generate the pile layout drawing, as it is the first drawing that will go to site for actually the pile itself. It will give you pile cap layout with pile cap numbers and markings for piles. And of course, the cross-section details and in-plan arrangement for the pile caps. For beam supported slabs, it will generate the general arrangement drawing, what we call GA drawing, showing the columns and beams marking and slab marking, etc. It will generate the top and bottom reinforcement details. So in here, typical top reinforcement detail. And it will generate slab sections the way you want in terms of how you identify it. Or if you handle a staircase slab with specified loading, it can create the staircase cross section as well. Detailed text reports are possible for calculations. So there is a design summary report, there is a detailed calculation report. For each of those elements, they are very much in detail, so I will not cover individually for each element. It will also generate bill of quantity. There are different types of bill of quantity. So there is a summary, there is a type reinforcement wise quantity, level wise quantity, and so on. So different elements, different method of presentation. And along with quantities, it will also give you quantity of shuttering. In case of foundation, it will give you a quantity of PCC, excavation, and so on. So this, in short, is what RCDC does. And a bit about Bentley's mission. So we believe as a company in supporting the infrastructure development worldwide. At the same time, we believe it has to be sustainable, and that's our commitment. And ultimately, it should lead to improved quality of life for everybody. You can search for various videos on different topics on YouTube channel, or you can visit our website. And in case you need any specific requirements for RCDC, you can reach out to me. Thank you. Now we'll have a quick demo of what RCDC is capable of. So let's say this is our structure, which has been analyzed for lateral loads, gravity loads, and the structure engineer has satisfied himself with the deflection pattern, the values of bending moment, and so on, whatever he wants to check. And now he wants to proceed to design. So he clicks here for advanced concrete design. And you specify the name of the project, the client, and the engineer, whatever you want. select the code that you want to have. So let's say I'm currently going for ACI 318 2014 and I'm going for columns and walls. Once I do that, it will read all the state data and will take you to the environment, which is RCDC UI. And in that, you can start the process of design post the reading is complete. As you can see, we have started already adding valuable input to your drawings or our final output. We have identified grids for columns based on the column center lines. Now, if you look at vertically each column, then you can see that we track the column with numbers vertically and number each column. So we started adding column numbers as well, not just the grids. So this is just the beginning. You can come here and set your grades for final design. Or you can go to your main design settings and decide whether you want to perform ductile design with intermediate or special type. What is the response modification coefficient as per what you have assumed in the analysis? What is your comfortable ratio for the wall? If you want to restrict up to say 0.9 of the critical capacity, then you can do that. If you want to design for crack fit, you can simply come here and check it, and so on. So let me not go into too many details here. Once you are here, you can set the parameters for design. So let's say I'm setting C35 as the grade of concrete for all the levels. And I proceed with the design. So what it asks you to correlate the primary load cases that you have selected. So let me say I have selected these load cases, and it will ask you whether the load cases that you have selected for wind and earthquake are they factored or unfactored as per the ACI. And in case unfactored, it will appropriately create combinations further. Now here so for design combinations, there are two options. You can directly add from analysis if you have defined, or you can add from standard template that is already available in the software. Or you could create your own template and save it and import it for any of the projects further. Now that's all. We are ready for design. So in the background, it will design all the columns as you can see here. So most of the column design is completed, and you can see all the columns designed. Each column is from one level to another identified here. As I mentioned earlier, you can do grouping. So how do you do that? So there is a report called snapshot, in which what we do is we identify each size of the column along its height and what is the variation in design. So you can see all the columns of similar sizes are automatically shown together with what is the final design percentage required. So looking at this report, you can define how do you want to group. So for example, let's say you decide that I want to group these columns. You simply group these columns and complete the design. Or you want to go further and create a group of all these 4 columns which are 600 by 900. You group the column, as simple as that. Or let's say you want to create a group of these 3 columns which are square columns, as simple as that. Also, if you want to group vertically, you can group levels. So you can come here and say I want to group these 2 levels and I want to group these 2 levels. Done. That's all you have to say. Internally, it will handle all the designs. So for each group, what it ultimately does is there are 3 columns here, for example, and 2 levels. So for each group, it will handle the combinations for all these columns for 2 levels and give you a final design. Now this is done, design is done. But if you want to further cross check, I want to change something, what can I do? So you can go to individual column and say redesign section. And once you come here, you see the actual bar arrangement that is being done. And let's say you are not happy with this. So you simply clear the bar diameter. And yes, say you want to have 1 bar less across both the directions. So you set the arrangement now, and it will design with this arrangement. Now in the background, it is doing all the checks, for slenderness, ductile, whatever is the setting that you have. If you are happy with this arrangement, simply accept it. And now let's say you want to try out this arrangement everywhere. So simply say copy and say you want to paste it in these 4 columns or these 3 columns and say paste reinforcement. In the background, it will check whether it is satisfying the design and it will allow you to paste only that. And you can see that there are ductile links created here because that was the requirement coming from the design. Now going to reports, you could create a detailed drawing. So it will look something like this. So let's say generate for all columns. So done, drawing is ready. And for whichever columns that were grouped, you can see that they are listed together with the arrangement. So this arrangement shows different bar types with different symbols. So it is easily you can make out what it looks like, and will show you link. If there is ductile detailing required, it will show you the confining zone, the height of the confining zone, and the different links that are in the different links. Also, it will generate elevation. So if you want to generate elevation, say for in this case, we'll generate elevation only for C7 because we want to see how the zones are created. And before that, if you want to go to settings, there are different settings possible. So it will ask you how do you want to provide lap, or how do you want to mark a section, or you want to show coupler or a normal splice, and so on. And it will create all of that data. So you can see very simply elevation is created across the height. It will mark the zones, different types of links in each zone, including the marking for the height and so on. So this is as detailed elevation as possible. For walls, it will generate detailed drawing for combined walls as well. So all generated, designed, completely generated, including the boundary elements if it was required. With the reinforcement arrangement, it will handle the junction detailing also on its own based on the worst of the 2 sides and so on. As simple as that. Calculation reports if you want to see. So let's say we go for a calculation report of say C2. So it will list the analysis file that was used, all the terms that are part of the calculation report, including the references to the code. Then it will show you the calculation for stability index, in this case is as per ACI code, and determine whether the floor is a sway or a non-sway. For each column, it will list the size of the column, the levels, the clear height based on the beam depth connecting to the columns. If it is grouped, it will show you how many floors are grouped. What is the most critical combination? For that combination, what is the effective light calculation, and then the slenderness check. If it is slender, it will add the slenderness moment here and finalize the design moments. And for that design moment, it will give you this final detail. At the same time, it will in the background check for shear in both directions, so shear along the major direction, shear along the minor direction. If it is required, it will do the interaction principle design based on both directions. And for links, if it is ductile links, it will do the special calculation for ductile links and so on. So this is a very detailed report for RCDC. If you want to see design for all combinations, you simply come here and select that. So it is an interesting thing. You can see this. So it is a simpler thing, a much more quick detail sort of thing. So it will list for each column all the combinations at top and bottom node. What is my final PU, final building design, and what is the capacity against the actual design requirement, and the maximum ratio for all those. Now in this case, there are 3 columns and 2 level groups. So it is listing for each, all of them individually for each level. You can see this. So it will create this data for 6 columns in actual on 2 levels and 3 groups. So this is as detailed as you get. Also, if you want to see how the interaction curve looks, so you can come here and say, I want to see the interaction surface. Done. So this is the interaction surface. This is the capping actual force that you can see here. You can slide here to see how it behaves vertically. So you can see this in the middle view, the changing capacity based on the location where the interaction curve is. or you can go across each combination and check what is happening for each combination, and it will show you the interaction. So this is as detailed as it can get. Or if you want, you can go for bill of quantities. There is a report called failure diagnostic. Currently, it is not available because none of them are failed. But in case some columns fail, it will give you a diagnostic in terms of telling you whether the column is failing for shear, or whether it is failing for axial force, or whether it is failing for bending moment, and so on. Also, you get bill of quantities, so you get different things. Let me quickly go through the summary. And if you fill the rates, you will also get the cost here. Unfortunately, I didn't check what was happening over there, but this is how the POQ happens. So that is it. That was a quick demo. Hope to see you soon. Thank you.